Welcome to Study Loop.
Okay, in this problem, we're dealing with air with a mass of about 29 times the mass per proton. We can assume for those air molecules and at a temperature at 300 Kelvin, we were asked to graph as a function of the velocity, the fraction of molecules in the total gas that are at that velocity. Note that we have the Boltzmann distribution for speeds, which is basically a probability density. It tells us in a certain interval at a particular velocity value what the probability density is for molecules to be at that velocity. And let's write down what exactly the distribution looks like. And it's the Maxwell distribution. So you have all these constants, m over 2 pi kt, 3 halves, v squared, e to the negative 1/2, mv squared over 2 kt. So this is Gaussian in form. Now, the important part is if we want to plot the fraction of molecules in a little velocity interval, what we can do, if we're looking at a velocity between v and v plus a little delta t, delta v rather, the fraction of molecules in that little interval is going to be the probability density, fv, the Maxwell distribution, multiplied by delta v all over big N. That would tell us the fraction of molecules. Now, if we compute this, I'll lay it out using our Maxwell distribution, expanding this whole thing. We can say that that is equal to 4 pi delta v times that constant to the 3 halves, which I'm not going to write it. Well, might as well. M over 2 pi kt, v squared, e to the 1/2 mv squared, negative 1/2 mv squared. Over 2 kt. So if we set our delta v to be the appropriate intervals that they asked for, which I believe is 50, we plug in our temperature of 300 and the Boltzmann constant and the mass of the air molecules, which is 29 times the mass of the proton. We can finally make a plot for this. I'll pull it up. Boom, there it is. So as I mentioned, because the Maxwell distribution is Gaussian in nature, we're going to get some kind of characteristic bell curve. So there it is. And that's going to give us the fraction of molecules at each of these individual bins. And we just connected the dots to make it a nice curve. And that's it. It's just interpreting what the Maxwell distribution really means. It's a probability density for molecules to exist at this particular velocity. When we integrate it in a little region, we get the fraction in that region.